Error code F7 on an air conditioner often indicates issues with the outdoor unit. The meaning of the F7 code varies depending on the equipment's brand. Here are the main interpretations. For Panasonic and manufacturer Voltas, the F7 code indicates a problem with the temperature sensor in the outdoor unit's heat exchanger or the air conditioner's condenser. For the brand Trane and manufacturer Haier, the F7 code indicates a failure in the compressor suction temperature sensor located in the outdoor unit. You can also identify the F7 error code on a Haier DC inverter type from the outdoor unit. To do this, observe when LED 1 on the outdoor unit's board flashes, indicating that this error code is displayed on the screen. It will flash 11 times on the outdoor unit, which means they have the same meaning. This indicates that the outdoor PCB has a fault when the suction pipe temperature sensor is open or short-circuited, showing F7 on the screen. If the compressor suction sensor is poorly connected or its connector is not properly seated, it will also display F7. Often, due to vibration, the connectors loosen. So by removing and reconnecting them, the error often disappears from the screen. Remember to check temperature sensors by disconnecting them and using a multimeter in the Killam scale to measure their electrical resistance. The measured value on the multimeter should never be 0 or infinite. Additionally, the electrical resistance value should decrease when the sensor tip is rubbed with the hand. If you have the equipment's catalog, check if it has the sensor's resistance versus temperature table to compare the measured values. For the Oris air conditioning brand, the F7 code means a very high temperature in the outdoor unit's IPM module, which powers the compressor. This code can appear when the IPM module exceeds 95 degrees Celsius. For this condition to occur, several factors are necessary, such as poor contact between the heat sink and IPM, excess dirt on the heat sink, or excessive current in the compressor. The first step to solving this problem is to physically inspect the electronic card to verify that the aluminum heat sink is firmly in contact with the IPM. It is crucial to de-energize the equipment before performing this test and wait for the necessary time for capacitor discharge. In addition to firm contact between the aluminum heat sink and IPM, it is essential to check that the heat sink fins are free from any dirt, such as dust or other substances that limit heat transfer. If the code persists after checking these points, it will be necessary to measure the current consumed by the compressor. If the current is out of range, it may be attributed to IPM overheating. Excess current consumed by the compressor is often related to refrigerant pressures out of range, a blocked capillary tube, or a dirty or poorly positioned condenser.